Today we're going to be looking at Lesson 3.4, Module 3, which talks about direct variation. In this lesson, the TEK that we're going to be focusing on is 8.5e, which is Solve Problems Involving Direct Variation. Now, direct variation is a new word to us, and what that means is that it's a special type of linear relationship. Okay, remember that linear means that our function, whenever we graph it, is going to make a straight line due to our constant of variation, or our slope, or our rate of change, or our unit rate. Okay, because of that being the same, it makes that linear line. So direct variation has to deal with our linear relationship. Now, discussing that relationship, okay, we can write it as k is equal to y over x. Remember that k stands for four things. It stands for our constant of variation, slope, rate of change, and unit rate. All of these things represent the same thing. So if we're looking at where direct variation comes from, I always look at this example to start out with. If we're going to Sonic and each drink is $2, so we're going to get these special prices. Okay, so if each drink is $2, first let's identify our x and our y. Let's say that y is the total cost of drinks and x is the number of drinks. So if I'm looking at this xy table that I drew off to the side, okay, x again represents the number of drinks. So if I have 0 drinks, 1 drink, 2 drinks, and 3 drinks, okay, I need to determine my cost. So if I have 0 drinks, the cost is going to be 0. If I have 1 drink, the cost is going to be $2. If I have 2 drinks that I purchased, the cost is going to be $4. And if I have 3 drinks, the total cost is going to be $6. Notice that I do have a constant. Each drink that I buy, I'm going to be spending $2 more. So with this being said, direct variation really means that the cost varies directly with the number of drinks that you buy. Okay, so depending on the number of drinks I buy, okay, is going to determine my cost. That's where we come up with the cost, which is my y value, varies directly with the number of drinks, which is my x value. So direct variation, just to summarize with this example, is that varying directly is really varies proportionally. Okay, I can find my constant or my rate of change or my slope because depending on the number of drinks I buy is going to determine my cost. Okay, so if there is a direct variation between my x and my y value, just like the one that we talked about, okay, this is really important that you remember. Y varies directly with x. Y varies directly with x. That's how we come up with our direct variation. So now, if we look at direct variation from a table, here's the problem. It says the table shows the widths and the lengths of United States flags. Determine whether the data set shows direct variation. If so, write an equation that describes your relationship. So remember, we're going to use two formulas to solve this problem. First of all, if we want to see if it shows a direct variation, first we're going to use k is equal to y over x to determine that constant. Once we find that constant, then we're going to plug it into our formula, y is equal to kx, to figure out the equation that is related to this table. So, first we have to find the constant, and we're going to use the formula k is equal to y over x. I've already set up the table for you. Okay, remember that in the xy table, if it's written horizontally, the top, which is my width, is going to represent my x values. The bottom is going to be my y values, which represents the length. So I'm really taking these ordered pairs, which would be 0.5 and 95 hundredths, okay, and entering those into my equation. So again, to find the constant, I use the formula y over x. Okay, for each point, I need to figure out what the constant is. So for 0.95 or 95 hundredths over 5/10, the constant ends up being 1.9. Okay, the next one, 2 and 375 thousandths over 1 and 25 hundredths is going to be 1.9. If I keep going entering these in my calculator, I will notice that each one has the same constant of 1.9. So with that being said, since each point has that constant of 1.9, I know that k is equal to 1.9. So once I've found my constant, now I can enter that into my formula. Remember, my formula is written as y is equal to k over x. So all I have to do is substitute 1.9 in for k. So my equation is going to be y is equal to 1.9x. This equation can work for that table and if I can find anything else related to this problem. So let's say the question extends a little bit more. And it asks, what is the width of the flag if the length is 4 23/100ths? Okay, so remember, length in our XY table represents our Y value. So if length is our Y value, that means that they're giving us the Y value. So I can extend this table and put in what they're giving me. Okay, so Y is equal to 4.23. Now I'm going to use that information to figure out what the width is, because that's what the question's asking me. So it's really asking me what this is right here. So I'm going to use my equation that I just wrote. Y is equal to 1.9x. Okay, they gave me y is 4 23/100ths, so I'm going to substitute that with parentheses in for my y. Okay, and I'm going to rewrite the whole equation. Now this is a one-step equation. So now to get x by itself, or to isolate x, right now the operation is multiplication. So the opposite or inverse operation of multiplication is division. So I'm going to divide 1.9 divided by 1.9, which equals 1, which cancels out, so x is isolated. Whatever I do to one side, I have to do to the other side. And when I enter this into my calculator, my answer is going to be 2.23. So the x value when y is 4.23 is going to be 2.23. Okay, and if I go back even more, remember that's what I'm solving for x. So the width is 2.23 feet. So that's extending on what we already know from our table. Okay, but that's a type of question that STAR may ask. Okay, so now if we're looking at direct variation in a graph, the graph of the direct variation always passes through the origin. Okay, and if you remember the origin when we talked about the coordinate grid, okay, the origin is the direct middle, which as a coordinate or ordered pair is going to be 0, 0. So if I give you these two examples, these are examples of our linear functions or linear graphs or linear relationships. Okay, notice that this first one falls through the origin. Okay, since it falls through the origin, this would mean that this is a direct variation. If you notice where this second one falls, okay, if I look at that y-axis, it falls somewhere in between probably -2, -3. Does not fall between the origin. So I know that this is not a direct variation example of our graph. Now, if I'm looking at the direct variation from an equation, okay, to determine if it's a direct variation, it has to be in y is equal to kx form. If it's not, then it's not considered direct variation. So if I look at this first equation, y is equal to 5x, it does fall in the form of y is equal to kx. So this would be considered direct variation. If I look at this next one, does it fit in the form of y is equal to kx? It does, however, it has that additional number that's attached to it. That additional number means that it does not form a direct variation relationship. Okay? Our equation has to be written in the form of y is equal to kx plus 0. That 0 is going to determine if it is a direct variation or not. So now let's put this all together. Okay, if I'm looking at this equation that I was given, it says one brand of motorcycle uses an oil to gasoline ratio as shown in the graph. The amount of oil that should be added varies directly with the amount of gasoline. Notice in that sentence, the amount of oil varies directly with the amount of gasoline. Okay, that sounds a lot like y varies directly with x. The amount of oil would be my y, varies directly with the amount of gasoline, which would be my x. So right away, I know that this is going to be a direct variation. So it says, write a direct variation equation that describes the relationship. Use your equation to determine the amount of oil that should be added to 6.5 gallons of gasoline. So first of all, I'm provided a graph. Again, if I look at my graph and my axis labels, remember we labeled the amount of oil as my y value. To double check, my amount of oil is on my y-axis. The amount of gasoline is my x value, and it is on the x-axis. So now remember, these points, okay, determine what is in our xy table. So if I look at these points, okay, this first point, okay, notice that each unit on the x-axis is going up by 5/10. So this is 0.5, and the y values are going up by 2. So 0.5 comma 2. That's my first point. The second point is 1.5 comma 6, which is my second point. Third point is 2 comma 8. Third point is 3.5 comma 14. And the fifth point is going to be 4 comma 16. So once I identify those points from my graph, I'm going to put them into my XY table. Now again, the question is making sure that we write a direct variation equation. So from my table, I need to determine if it's a direct variation. I need to find the constant, which means I need to use the formula y over x to figure out my constant is. So for this first point, labeled in my XY table, my y value is 2 divided by 0.5. Calculator, I get 4. I'm going to do that for every single problem or every single coordinate that's in my XY table. 6 divided by 1.5 is 4. 8 divided by 2 is 4. 14 divided by 3.5 is 4. And 16 divided by 4 is 4. Since my constants are all the same, with all of my coordinates that are given, I know that my constant is 4. Once I've figured out my constant, now I have to write an equation. So remember, the equation form is y is equal to kx. So all I have to do is insert that 4 in for the k. So my equation should be y is equal to 4x. Okay, so from my question, I already have written the direct variation equation, which describes the relationship. Okay, and now I'm going to use my equation to determine the amount of oil that should be added to 6.5 gallons of gas. Look at gallons of gasoline. Okay, that's on my x-axis, so I know x is equal to 6.5. So if I want to determine the amount of oil, which is my y value, I'm going to use my formula and plug in 6.5 in for x. So again, my formula is going to be y is equal to 4x. Since they give me x is equal to 6.5, I'm going to plug 6.5 in for my x value in my equation. Remember, whenever you substitute a value in for a variable, you have to put it in parentheses. And now I'm going to solve. 4 times 6.5 is going to be y is equal to 26. Now if I was to answer that even more specifically, remember my y value is the amount of oil in ounces. So my correct answer would be 26 ounces of oil. So just to summarize what you've learned today about direct variation, these are the important facts that you need to know. Okay, first of all, with direct variation on a graph, direct variation means that it's going to go through the origin of 0, 0. That would be direct variation. Direct variation is not a linear relationship that goes through at any point other than 0, 0. If it was determined if it was direct variation for an equation, okay, my equation would be y is equal to kx plus 0. An equation that is not considered direct variation would be y is equal to kx plus or minus any number. And then to determine a direct variation from a table, okay, since it goes through the origin of 0, 0, my table has to have that point 0, 0. Okay, and then if I extend it, it has to have that constant rate of change. A table that does not have direct variation would be a point that would not go through 0, 0. So let's say 0, 5, sort of like what our picture would look like. If I was to graph this point, start at 0, go up 5, that would not go through our origin. Okay, but it could still have a constant. It can have a constant, but it does not go through 0, 0. So that means that it is not a direct variation. Okay, if we go back and look at our TEK of what was our goal today, okay, of solving problems involving direct variation. You solved 2 problems using direct variation just from today's notes, okay, and tomorrow when you get into class we'll be doing a lot more, so make sure you come prepared. This part right here of what we just summarized is going to help you solve any problem and identify if it has direct variation or not. I'll see you tomorrow, and thanks again for listening. Have a great evening.